Welcome to Think Global Education Services. Today's topic is momentum, especially linear momentum. In physics, linear momentum is represented by the letter P. It is given by the letter P, and it is defined as the product of the mass of an object and the velocity of that object. For instance, let's just say this is a ball, and its mass m is given by 10 kilograms. Now let's just say this is moving at the velocity in this direction. This is the velocity, which is equal to 10 meter per second. And we can calculate the momentum of this ball as momentum P equal to mass 10 kilograms multiplied by velocity 10 meter per second, which is 100. And its unit is the product of the units of mass and kilogram. That is, unit of mass is kilograms, unit of velocity is meter per second. So kilogram meter per second. So this is the linear momentum. Now we know what is Newton's second law. Newton's second law is given by force is equal to mass times acceleration. Now here velocity is a vector quantity, so momentum is also a vector quantity. Similarly here, force is a vector quantity and acceleration is a vector quantity. And we know what is the definition of acceleration, which is the rate of change of velocity. So it is represented by change in velocity divided by change in time. Here the symbol delta represents the change. So we can rewrite second law as F vector equal to mass m times delta v divided by delta t. Now we can rewrite it as delta mv by delta t. Now we know what is mv. mv is nothing but, so here we have to put vector symbols. So here mv is nothing but p, so we are going to put delta p divided by delta t. So from this equation we can get that force is nothing but the rate of change of momentum. Rate of change of momentum is the force. So from this equation, what we can deduct is that momentum will always be in the direction of velocity. That is, the velocity is, let's just say the velocity is from in this direction, that is north, then momentum must be also in the same direction, north. So likewise, here we can say that momentum is in the north direction, so force is also in the same direction. So that is the concept of momentum, linear momentum. Now we can discuss about linear momentum in a system of particles, or momentum in a system of particles. So we have discussed about momentum of an object. Now what if we had more than one object as a system? That means, let's consider this is a box. And in this box there are many different objects. Now the mass of this object is m1 and mass of this object is m2 and mass of this one is m3, and their respective velocities is m1, m2, sorry, v1, v2 and v3. Yes, so m1, v1, m2, v2, m3, v3, that is the momentum of these particles. Now what is the momentum of this box? So momentum of this box is given by m1 times v1 plus m2 times v2 plus m3 times v3. So that is the total momentum of the box. So we can get a general equation from this simple example, that is total momentum of any system of particles. This total momentum of system of particles with the n number of particles is given by total momentum P is equal to m1 v1 plus m2 v2 up to mn vn. So this is an introduction to the concept of linear momentum. Thank you for watching.